Hello everyone. In this video, we are going to talk about the IUPAC nomenclature of alkynes. An alkyne is a hydrocarbon with a carbon-carbon triple bond. Their general molecular formula is CN H2N minus 2. The carbon atoms where the triple bond is present are sp hybridized. The sp-sp head-on overlap creates the sigma bond, whereas the sideways overlap of the p orbitals, two different p orbitals, this creates one pi bond, this creates another pi bond. So, we have one sigma bond and two pi bond. This means that the bond angle is going to be 180 degree. Unlike alkenes, where we have to see whether the molecule exhibits cis trans isomerism or not, we no longer need to worry about cis trans isomers in this case, because you can only attach one atom or a group on each side of the triple bond. That itself satisfies the tetravalency of carbon. Alright, let us look at some examples and do their naming. We just have to follow the same rules as we did earlier in the case of alkenes. The only difference is we have a triple bond now. So, our suffix is going to change now from E into ine. So, let us do the numbering 1, 2, 3, 4. We have 4 carbon atoms in the parent chain, and therefore, this is a butyne. So, we need to mention the location of the triple bond, and therefore, we have to call this molecule as but1ine. We need to give the lowest locant for the triple bond position. Let us go to the next one. So, in this case, which one to pick it as a parent chain? That is the main question. If we pick this whole thing as a parent chain, then we have an isopropyl group. But on the contrary, if you pick this as your parent chain, we still have 6 carbon atoms, but now we have 2 different substituents. So, 6 carbons, 2 substituents. In the earlier case, we had 6 carbons, 1 substituent, and therefore, this is preferred. So, let us do the naming 1, 2, 3, 4, 5, 6. At 4 position we have an ethyl group, 5 position we have a methyl group. We should not do the numbering on the other way around, because if we do the numbering on the other way around, then the alkyne, the triple bond will get a higher number. It will be 4ine. That we should not do, and therefore, the correct IUPAC name for this molecule is 4-ethyl 5-methyl. We have 6 carbon atoms in the parent chain, and therefore, hex 2-ine. That is the correct IUPAC name for this molecule. Let us look at more examples. In this case, we have a cyclic system connected to an acyclic system, but it is the acyclic system that has the triple bond, and therefore, the parent chain is definitely going to be the acyclic one. However, the question is which one to pick. 1, 2, 3, let us start numbering. Now, whether to go down or up. The best choice in this case should be this one, because that would give us most substituted parent chain. In this molecule, we have 4 different substituents, the cyclopentyl ring, and then we have an ethyl group, and then 2 methyl groups. So, in total we have 4 substituents. Let us finish the numbering. 1, 2, 3, 4, 5. We should not do the numbering on the other way around. If we do the numbering on the other way around, then the alkyne will get a higher number. That we should not do. And therefore, the correct IUPAC name for this molecule is 1 cyclopentyl. This 1 refers to this one, and then 3 ethyl, and then 4, 4 dimethyl pent, because we have 5 carbon atoms in the parent chain, 1 ine. That is the correct IUPAC name for this molecule. Let us look at next example. In this molecule, we have an alkene as well as an alkyne. So, how to do the naming? If we do the numbering from left to right, 1, 2, 3, 4, 5, left to right, 2 position in, 4 position ine. On the contrary, if we do the numbering from right to left, 1, 2, 3, 4, 5, right to left, 1 position ine, 3 position in, 1, 3. As per the IUPAC rules, multiple bonds are treated as a set. Here what we mean by multiple bonds is both double bonds as well as triple bonds. They are treated as a set. When a choice exists, then you can give preference to the double bonds, but we do not have a tie here, and therefore this is the correct way of numbering in this case. While studying the precedence of functional groups, you might have studied that carbon-carbon double bond gets more preference than the carbon-carbon triple bond. However, we cannot use that here and choose this as our best numbering scheme. In that way, you will be giving a wrong IUPAC name if you use that one here. That you can use it only when there is a tie. If there is no tie, if both of them were 1, 3, 1, 3, in that case you can use it. If both of them were 2, 4, 2, 4, in that case you can use it. But here we do not have a tie. So, it is the numerical order that we have to follow, and therefore, this numbering scheme is correct. Now, before naming, we also have to decide about the EZ isomerism, whether it is an E isomer or Z isomer. We have a hidden hydrogen atom hidden here, hydrogen atom hidden here. So, as per the CIP rules, carbon gets more preference compared to hydrogen here too. So, your higher priorities are on the same side, and therefore, this is a Z isomer, and therefore, the correct IUPAC name for this molecule is pent, in parenthesis 3Z, in, we are dropping the E because what comes next is ine, that is another vowel coming up, and therefore, we have to drop the E, 1 ine. That is the correct IUPAC name for this molecule. Alright, let us look at the IUPAC name for this molecule. If we do the numbering right to left, as we did in our previous example, in that case 1 and 3, at 1 position you have the alkyne, 3 position alkene. But on the contrary, if we do the numbering from left to right, 1, 2, 3, 4, 1 and 3 once again, but at 1 position we have the alkene, 3 position alkyne. So, we have a tie. So, which numbering scheme we should choose in this case? Whenever there is a tie, preference must be given to the double bond, and therefore this numbering scheme is correct right now. So let us do the naming, but before looking at the naming, let us assign the priorities, because we need to mention whether it is a E or Z isomer. Bromine will get the top priority on this side, carbon will get the least priority. On the contrary, on this side, fluorine will get the top priority, the hidden hydrogen will get the least priority. So, the priorities are on the opposite side. This means that this is an E isomer, and therefore, the correct IUPAC name for this molecule is 2-bromo, we still have to follow the alphabetical order, 1-fluoro, bute, in parenthesis 1E, ene, we have to drop the E because ine comes next, and therefore, if we mention the E, then 2 vowels are coming successively, therefore, we have to drop the E. 3 ine, that is the correct IUPAC name for this molecule. Let us look at one more example. We have a cycloalkadiyne in this case. While studying the cycloalkanes, you might have studied that the more branched carbon gets the lower number. However, that rule we cannot apply here. Here we have a triple bond, 2 triple bonds are there. So, that we need to treat it as a functional group, and therefore, the numbering has to start from here 1, 2, 3, 4, 5, 6, 7, 8. So, our parent chain has 8 carbons. So, it is a cycloalkadiyne with 2 substituents at position 3, and therefore, the correct IUPAC name for this molecule is 3-ethyl 3-methyl cycloalkata. Because it is a diene, we are putting the A. 1,5 diene. That is the correct IUPAC name for this molecule. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media for more useful contents. Thank you.